Let's have a discussion about working of three-phase induction motor. For understanding the principle of three-phase induction motor, we first look at the basic constructional feature of this type of motor. This motor mainly consists of two major parts. First one is stator. Stator of this motor is made up of number of laminations of cold grain-oriented silicon steel to reduce hysteresis and eddy current loss. The inner periphery of this cylindrical stator is provided with number of slots. A three-phase winding is so similarly distributed among these slots that when a three-phase power is supplied, a rotating magnetic field is produced. This magnetic field rotates at a synchronous speed. Second one is rotor. Rotor of a three-phase induction motor consists of cylindrical laminated core with parallel slots. Conductors are heavy copper or aluminum bars, and they are short-circuited by an end rings, which fit in each slots. Now, initially when the rotor is standstill, the flux of rotating magnetic field cut every solid conductor of the rotor. As the rotor conductors are stationary and sinusoidal stator field is rotating, there will be a change in flux linkage with the rotor conductor. As a result, there will be an induced current in the rotor conductors as per Faraday's law of electromagnetic induction. Whenever this current starts flowing through the conductor, it reacts with the magnetic field. Again, as we know that current carrying conductor inside a magnetic field experiences a mechanical force. Hence, here a mechanical force will be experienced by the rotor conductors. Due to this force, the rotor will start rotating inside the stator, and the rotor will try to achieve the speed of rotating magnetic field. Once the rotor achieves the speed of rotating magnetic field, there will be no relative speed between the rotor and the rotating magnetic field. Hence, there will be no current induced in the rotor conductor. That means, at that condition, no mechanical force acts on the rotor conductor. Hence, the rotor decelerates. As the rotor decelerates, again a relative speed between rotor and rotating magnetic field is re-established, and hence there will be again current induced in the rotor conductor, which causes mechanical force to act again on them. As a result, the rotor again accelerates to reach the speed of the rotating magnetic field. Due to this phenomenon, the rotor will never reach the speed of rotating magnetic field, and also the rotor will not stop rotating till the three-phase power is there in the stator. Actually, the rotor rotates with a speed slightly less than the speed of rotating magnetic field. This is how a three-phase induction motor works. Thank you.